What is a bearer token? Let's discuss part 1. So one choice made by OAuth working group while designing the OAuth 2.0 specification was to drop the custom signature mechanism present in the original OAuth 1.0 specification in favor of relying on secure transport layer mechanisms such as TLS between parties. So right now we all used 2.0 specification, but earlier when you go to 1.0, then there is a challenge there. Maybe I'll just show you in the next slide that what is the challenge and why it's a frustrating part. That's why the group has built a new specification, and then yeah, it's a different way how we are using that. So by removing the signing requirement from the base protocol, OAuth 2.0 can accommodate different kinds of tokens. The OAuth specification defines a bearer token as a security device with the property that any party in possession of the token can use the token regardless of who that party is. In this way, a bearer token is much like a bus token, or you can say a ticket to an amusement park. These items grant access to services and don't care who use them. As long as you have got a bus token, you can ride the bus. Yeah, the same thing we see in the bus or maybe the amusement park. They don't care, right? Who we are. We're just paying an amount. They are giving us a token, and for some period of time, maybe till the time we are using their service, the token is valid. Right? Whether we are riding a bus or maybe going to an amusement park, anything. From a technological standpoint, you can think about bearer tokens in much the same way as you do browser cookies. Both share some basic properties, but there are some differences also. So basic properties, when we can say this, the same basic properties, they use plain text strings, no secret or signature is involved. TLS is the basis of the security model, but there are some differences also. What are those? Browsers have a long history of dealing with cookies, whereas the OAuth client don't. Browsers enforce the same origin policy. That means that a cookie for one domain is not passed to another domain. This is not the case for the OAuth client. So we have some differences and some similarity. The original OAuth 1.0 protocol called for tokens that also had an associated secret. So in the OAuth 1.0, what happens? So you have a token, and then you have associated secret also. And what the use of that secret is basically used to calculate a signature across the request. This signature was then verified by the protected resource alongside the token value itself, proving the possession of both the token and its associated secret. That means you have a token and you have an associated secret. Using that associated secret, basically we are creating a signature, and then we are sending this information along with the token to the receiver, or you can say to the protected resource. Now it's the protected resource responsibility to do the validation of that, right? You were just verifying that using that signature, and then just proving the position of both the token and its associated secret. So it's just a same thing what we previously seen, right, in the digital signature concept. So how if I need to send some message like from one party to the another, right, from sender to receiver, then I have the message, and then I have the digital signature. So I'm just sending this to information to the receiver, and the receiver is just how it basically decrypt that digital signature with the public key of the sender, and then get the unique hash value, and then also calculate the unique hash value for the message, and then just try to compare that. So it's a kind of same concept, similar concept, right? Now see how this is creating a problem. Calculating this signature correctly and consistently turned out to be a big burden for client and server developer. And the process was prone to many frustrating errors. Calculating the signature depends on many factors. Correct. So basically we need to calculate the signature, and depends on many factors such as encoding string values, or ordering the request parameter, or and canalization of the URI. So in combination with the fact that cryptography doesn't forgive even the smallest mistake, things constantly broke because of mismatching signatures. So yeah, this is a concept of the cryptography, and in the cryptography you know already, right, that if there is a mismatch of single character, anything like that, it will fail, and it's keep happening like that. It's a frustrating for the client and server developers. So, let's see this example also, like through which you can understand that the problem in this OAuth 1.0 specification, the token, the way it's basically communicating. So for instance, a server-side application framework could inject or reorder parameters, or a reverse proxy could hide the original request URI from the application doing the OAuth processing. One of the authors knows firsthand of a developer whose OAuth 1.0 implementation used an uppercase hex encoding on the client side and lowercase hex encoding on the server side. Okay, so this is the difference, right, in the implementation. So we have uppercase hex encoding at the client side, and on the server side we have the lowercase. This particular implementation bug was infuriating to discover. Although a human can easily see this as an equivalent, and any machine interpreting the hex value can easily transform it. So let's talk about the machine or the human. There is no issue in this, because yeah, if we can just it's just a case sensitive part, right? The data is same. But when coming to the cryptographic things, cryptographic functions requires an exact match between both sides in order for the signature to validate properly. And here there is a difference, right, in the encoding, uppercase and the lowercase hex encoding, and it's failing. So this is one of the example what we have seen. Yeah. Furthermore, the requirement for the TLS never went away. Without TLS for the get a token step, the access token and its secret could be stolen. Without transport layer security for the use a token step, the results of the authorized call could be stolen and sometimes replayed within the time windows. As a result, OAuth 1.0 had the reputation of being a complicated, difficult to use protocol. And then there is a new specification discovered, that is OAuth 2.0 was formed with the bearer tokens at the center of a new simplified protocol. Message level signatures were not entirely abandoned but merely set aside, so that the custom in the previous 1.0 we see, right, the token along with the secret, and that secret is basically used to create a signature, calculate a signature across the request, and then we have the validation for that. So we haven't abandoned that part but merely set aside. That means with time some users of the OAuth 2.0 specification asked for an extension of the protocol that included some sort of signature, and that we see right now, right? If you just decode the token, you see there is a header, payload and the signature part. So that is used for, yeah, just proving the position part, the same thing, like but yeah, again it's a difference. Not it's not in the similar way what we have in the 1.0, because in 1.0 we have a token and secret, and then we are calculating a signature across the request, and then this it's a burden, right? It's a frustration what we have seen if there is a not exact match, right, that we have seen in the cryptographic function. So those things were removed, and yeah, it's much easy to use, and yeah, as we are currently using also. So let's talk more on that part, like what are the risk and consideration of this bearer token. So in this section, yeah, we just talked about the basic bearer token. Right now, maybe you have seen, right, how you are getting a token, and then you're just passing that. We have seen, right, in the previous examples that we are passing that access token as authorization header, and then calling the APIs, and then yeah, getting access to those resources. So right, so that's not a burden for now, right? But in the 1.0 specification we have that we need to pass signature and all other things. Okay, so this is one thing, and let's jump to the next where we'll talk about risk and consideration of using bearer tokens. Okay, yeah, thank you.